Good afternoon, everyone. Good afternoon. If anyone is already joined online, please give me a thumbs up on sound. All right, so we're about to start. We are going to start in a couple of minutes just to let some people come in. Thank you for being here today. All right, everyone. Good afternoon. Welcome to today's presentation. This is our holiday edition. I hope you're having a great time with family and friends. Um, for those who work on data engineering, I believe this presentation is going to be exactly very helpful to just basically provide some background about a data engineering process-oriented approach. So basically, when we start talking about data engineering, we um, we tend to think about the business requirements, the goal of the project, the scope of the project, and how to implement it by building out the design and the architecture of the project. One of the areas that does not get covered a lot during this discovery process is how are we gonna provide um, basically traceability on what we do, be able to build something that is modular and that it can be audited, right? And these areas are very important because these are areas that we cover during data governance discovery. And the whole purpose of data governance is to be understand clearly. In addition to security, right? A lot of people think of governance just in the aspects of who has access to data, who can see data, what data can you see, and so on. But data governance also covers a lot of the metadata information that should be available in a project to be able to understand where the data comes from, how is the data processed, where's the data stored, what are some of the policies for expiration, and so on. So if you're new to that, then today is a great presentation, and I'm going to cover some of that information with you. So thank you for being here. My name is Oscar Garcia. My areas of expertise are around architecture with cloud data and AI technologies. I'm passionate about building innovations, solutions, and I love to share what I learn with others. Um, I'm also the author of the book Data Engineering Process Fundamental. I think this is an important for me, has been very important in my career to sort of kind of put my thoughts together about how I see managing projects and running projects with the data, with the process oriented approach. And that book covers some of that. So if you can take a look at it, you can scan that QR code as well. That takes you to a portal where I have GitHub projects and information that you can use. By the way, all this information is available on GitHub. Everything that you're seeing today is available on GitHub. So you can go ahead and basically use it. In addition, we're live on YouTube also right now. So we are uh, casting this meeting there. So you'll have recordings of everything, as well as the source code and all of the information about this presentation. So welcome, everyone. All right, let's get started. So what is a data engineering process overview? I think this is very important for us to understand and review every time we have one of these presentations, right? But the whole idea here is really to kind of understand that when we start a data engineering process or project, we need to follow a series of steps to be able to meet the deliverables, right? To be able to understand how to execute the project and be able to deliver something that is functional to the business, right? So some of these processes are basically the discovery phase, design and planning, data pipeline and orchestration, data modeling and data warehouse, data analysis and visualization, and data governance. In today's presentation, we are basically focusing on the data warehouse approach to be able to support data governance. There are other presentations that we do online. There's recordings on GitHub, on YouTube that you can go ahead and take a look. But it's important to kind of view all of this information so to understand what the process really is. You can also follow that GitHub project that you see. And basically I'll paste that information, but it has all the information that we are covering today and more. All right, so our focus today will be this medallion. So in reality, this architecture is really a data management, and the intent here basically organize data into layers based on its quality and processing level. So what this really means is that we identify a series of layers or stages where we actually process our information, and as we go up the data quality ladder, then we are improving the data, right? So the goal here is to really improve data quality, but by separating into different zones, right? And that could be like the bronze, silver, and gold. And we are going to speak about each one of those as we move forward. We also want to enhance data governance when we need to provide clear data ownership and lineage to basically be able to have visibility over the process of the data, how the data is processed, how formed, and who is using it. So that's very important. Then this enables us to have accelerated insights, right? Because at the end of this process, we are optimizing the data insight that we are enabling data analysis with dashboards or even data science if you are into that industry. It's also scalable. This enables us to not just dump everything into one table and just have this massive table that it doesn't perform when you do queries. And on top of that, is not cost efficient because if you process this on databases or data warehouses in the cloud, there's performance and data costs associated with this, right? So let's continue. All right, so let's start with the row zone, right? The row zone is the foundation of our data lakes. Okay, so what are these terms? Right? So basically, first of all, the data lake is some level of storage that we have and that you can set up on cloud, Google Cloud, Azure, and so on. And the intent here is to use a blob storage infrastructure to be able to copy raw data from external systems, right? So that's why it's called a row zone, because it enables us to move data as you do exports, maybe JSON, CSVs, maybe some data stream that you are creating files in there into our data lake. Then these files are copied or exported to this raw data as they look from the system of record, right? So there is no cleaning, there is no transformation. It's just for high volume and velocity. And it's crucial here because you're going to have massive amounts of data to use something like this, like blob storage, and not go directly into a data warehouse because the cost of storage increases, right? So it's important to have that in mind. But the goal here is to also establish data retention policies that are important. So meaning, are you going to keep the data for 3 years, 4 years, 5 years, and so on? So that's really important because is part of cost management of your data governance process, right? So the benefits here are definitely is lower costs, enables now the data processing from a data warehouse standpoint, or maybe if you're doing Python development, where you can connect to this data lake and get the data, raw data the way it is, and do data analysis, run your data discovery, and be able to understand what's available. Right. So that's the first step, right? So the data is placed into the data lake, and of course, behind that, the mechanisms to load the data into the data lake is part of that data pipeline, right? So that's where we build the data pipeline, where it's probably just reading data from one base, exporting it to the data lake, or calling some web service and so on. So the data pipeline, there's a whole concept of that, a presentation on that, and that is available on GitHub also. But right now we're focusing mostly on the data warehouse and data lake, data warehouse, data processing for data governance purposes. All right, so now that we have the raw data, right? So we move on to the first layer, and this is really the now the bronze layer, where we actually create the concept of a staging data. This is where we actually now start looking at the raw data from the data lake, and we start doing initial cleaning, structuring, and transformation. So basically what happens here is that the data, the raw data may have just CSV files or JSON files, right? Parquet files. They can be compressed, gzip, right? But there's no schema definition. There is no data type mapping. Maybe everything is string, which is incorrect. Maybe the dates and times are separated. Many things can happen, but this is the moment we really start and defining the schema for this data. So here we start thinking about structuring this data into views for the purpose of staging the information. So, but to be able for a data warehouse to be able to consume this into views, we have to create a concept of an external table. And the external table, all it is in this data warehouse and modern database systems these days, is that you can actually, instead of importing records into a table, you can actually map to a blob storage or data lake and be able to create a sort of a mapping connection into those files. And those files can support wildcard patterns, so you can import multiple files with just a single mapping. So that is the concept of an external table. So the purpose here is to the data warehouse, the external table just looks like a table, right? Which now you can use and read using SQL statements. And you can get that information from the data lake. The benefits: improves your data quality and consistency because of the approach. You're not just dumping data into one table and doing mappings without having maybe a very good understanding of what the data looks like. But by building external tables and then views on top of those external tables, you're kind of doing data modeling. So at that point, you're doing my definition, you're doing the data dictionaries, you're doing data modeling. So it's a great process to sort of understand clearly what the data looks like. Okay, so now we did the bronze zone, the staging area. So now from our data warehouse standpoint, we have a set of views that are actually giving us a window to the raw data, to the data lake. And now we can now just use additional tools to be able to now build out tables, materialize the views that we're using into the data warehouse. So with the silver zone here is when we start building out the foundation for data analysis, right? That's where we're saying now, okay, let's refine and optimize these views, right? This is now when we start building, maybe depending on what you're trying to achieve, you build materialized views, or you basically start building your data models in the sense of uh, your dimension tables, your fact tables, and so on. So this is that stage now where we're actually building out the different type of tables to be able to clean the data, standardize, and enrich the data. So basically what happens, the raw data can have multiple files, and the naming conventions of the column names could be completely different, or the names are completely different. So this is the process now where you try to model your data and standardize the names. Maybe you want to use lowercase for all the names, right? And you start making sense of the data in a model way. Instead of reading a file that has 70 columns, you start building out the models, right? You start understanding that this file can be broken into 3 or 4 dimension tables, and a fact table or 2 fact tables, depending on what you're trying to achieve. But then you start thinking about the schema design, right? The schema model for data warehouses, where you actually have uh, um, a design where you can join basically on foreign keys, and you can actually, instead of having one row table, you can actually start looking at dimensions like the station name, or the station data, or the booth data, or the line data. And this analogy works because what I'm talking about right now is the example I use on the GitHub repo. So the data is really data for a subway system. So the models are, for example, a train station, a line where the train runs, right? Like ABC, and the booth where people enter in and out of the station. So all this information is relevant for that type of understanding. So you can target and understand how many commuters are running on a particular time on that particular station or line, and so on. So that's the analogy, right? So, and you can read this more in details on the GitHub repo. But the idea here is now that we structure the data, we can normalize it, denormalize it based on need, right? Normalization is building out the dimensions and the fact table. Denormalizing, you may need that for performance for some instances where you don't need that level of structure, and you just want a flat table, basically. It really depends on what you're trying to achieve, right? And of course, this is where we start doing data partitioning and indexing, clustering, and so on for optimization of our queries, right? So the benefits, of course, improve query performance and support self-service analytics. And of course, also reduce query costs, because one thing to be mindful of in data governance is that if there is no need to retrieve so much data, then you shouldn't, because there is a cost associated to that, right? So by clustering, partitioning the data, then you basically are achieving, you are improving the lowering the cost, because it's only going to retrieve data based on your clusters, right? So be also mindful of that information, of everything is, there's a cost associated. So when you make decisions, in addition to performance and quality, you want to also manage the costs. All right, so now we we decided to create our tables, and maybe we went with a sort of a schema that enables us to build out the star schema builds out the dimension tables and start and fact tables and so on, right? And we can do joins, right? We can select, build our select statements, and actually join all these tables and get the data the way we need. But there's some cases, well, this is very common, right, where we actually now need to curate the data sets for business users, right? Because business users don't really understand this concept of, I'm going to select dimension tables and fact tables and create different views and all that. They need the data in a way that is easy for them just to basically read and maybe copy into a spreadsheet or into a dashboard, and they don't have to be breaking their heads trying to understand the data, right? So The goal here is to actually create, handle the complex transformations and optimizations of the business rules into the goal zone. So the goal zone, basically, if let's say if it is some kind of financial analysis, maybe there's an optimized table there for financial analysis that takes all the data as incremental updates are running in the system. As incremental updates is when additional data is coming in, right, into the system. Then this financial table, statistic table, is handling something that the financial team can just read off of it and get the data the way they want it. So it's important to do that. So a lot of the common examples here is to do data aggregation and summarize it for specific use cases like financing. Um, if you're doing, for example, some reports that are actually very important, but they're massive on the data aggregation and so on, maybe you want to materialize that, right? And materialize that for performance. So you're not, if it is a high demand data set, that you're not allowing people to query that too often, because that's a cost. There's a cost associated to that. So you want to materialize that and actually manage the policies to refresh that data, right? Because with materialized data, you're just basically inserting data into an object where you need to refresh it. And with new data warehouse technologies, that's easy as a configuration to a data lake and some kind of timing settings to be able to say refresh this materialized table in this with this frequency. So many things there. Just to the point here is to understand all these different considerations, right? So with the goal zone, we also worry about making sure the data is secure and governed, right? And what that really means is who has access to the financial table, basically, and that's probably just the financing team, not everyone else, right? And so on. So that falls now under the governance umbrella, and that's where you actually now need to start breaking down and optimizing security, so the different teams like financing team, customer service team, and so on can have access to the data they need with the right for the right team, right? Not having customer service access the financing or financial tables, right? So the benefits of this is that it enables rapid insights and decision making for the teams. The teams don't have to worry about what the data should looks like and so on. They just worry about, I need to consume my data and make my decisions based on those insights, right? It supports self-service and reporting, right? So self-service analytics and reporting is each team is can do their own analysis. You don't have to have a special 2 or 3 developers just whipping out reports, right? So that's the goal, to achieve this goal zone. So it makes it easier for self-service, so you don't have to be spending or allocating resources, developers, to be building reports for different teams. And in some cases you'll have to, but it could be the ad hoc report. But the idea is the goal zone purpose is to build it out in such a way so teams can consume the data. All right. So, and again, a goal zone is the goal here is to empower instant action, is really to provide that data set that is easy to consume and is optimized for teams to be able to consume it. And the goal here is to be able to use it in dashboards, data science, machine learning models, applications, right? To be able to present to the business what they need, right? What they need in the sense of what is the data for the quarterly report, monthly report, and so on, so they can actually make decisions and take action based on what they see from the system. Some of the tools that the consumers will use are BI tools like Tableau, Power BI, Looker, spreadsheets, right? Like Excel and so on, right? For data scientists, we're looking at things like Python, SQL, right? Different programming languages to be able to query the data and do whatever they need to do. For machine learning, we can use TensorFlow, PyTorch, and build those machine learning models to be able to do that. And there's also a bunch of analytics tools that we can use that will consume that, and they have boilerplates, dashboards, and analysis to be able to generate what the business needs, right? So that's important. But the end goal of the goal zone is to enable that level of analysis from our data sets. So that all that work, all that conversation really is to start thinking about data governance, right? So which is really the foundation for data management. So this is where we define how the data is managed in one organization, right? In any organization, right? Data governance really is essential for ensuring the data quality, consistency, and security of the system. So a lot of people know about security. You hear governance, and that's the main point. People think, oh, it's because it's security, right? Who has access to that data? But in reality, it involves more. For example, there's the concept of data lineage. And data lineage basically tracks the entire journey of that data. So for example, if I'm really looking at a report, let's say I'm looking at a Power BI or a Looker dashboard, and I'm looking at that and I'm looking at the results, and I want to say, you know what, there's something with this data. Where's this data from? How did it get here? What was the whole process to get it here? So lineage will tell you exactly, as you track, it will the process of that data. It will tell you exactly where it came from, all the way up from the data lake. You'll be able to see that some of those records came out from a data lake bucket from this external system, right? Or external partner. So it will give you that traceability, which is important, right? Those are data governance terms. Be able to have traceability to understand how that data got here. So that's very important. It gives you data ownership, right? What team can see what, right? Who owns what, right? Who, as from the business perspective, who validates the data that we're presenting is accurate and useful for the purposes. Because as a data engineer, you may not have the business expertise. You understand data and you understand statistics and how to build that data and how to refine it and clean it, but you may not really understand the business requirements of the data, and you may not be presenting the data in a way that is accurate for what the business needs. So you have data ownership, right? You have data stewardship, where we need to manage the data on a day-to-day basis, right? Ensuring quality and compliance. So that person is the one that's making sure, or that role is to make sure that that pipeline is moving, is running, that the external business is not for some reason failing to provide the data, right? Because it could be completely outside your data pipeline. It could be coming from an external partner and they are failing to submit some of the data that we need. So that's important. We get to the very important area, which is now data security, right? And that's really to protect the access to the data. Who can see what? Is the data encrypted? How is the network secure? What are the recovery plans, and so on? And this data security is a massive undertaking, right? It has a lot to do with network and infrastructure, as well as security, right? So, and of course, compliance. Depending on your business, there is the concept of compliance. So, if you, for example, if you in the medical industry, HIPAA compliance is super important, right? If you're managing payments, processing payments, that you have to follow certain compliance for to manage consumer information, payment information, and all those things, right? And that is to always encrypt data at rest and not authorize certain people to see critical data, right? Excuse me. Okay, so that's basically the whole foundation of data management for when it comes to data governance. So we talked a little bit about incremental updates, right, and data transformation. And as part of data governance, it's very important to understand how this how this data flow, right? How where did the data come from? What kind of stages did it go through? And to be able to go back and trace it back to understand where there may be some problem, some failure, right? So it may fail for some reason. So here's where we start looking at the data extraction, the cleaning, loading, maybe the typecasting. Um, and this is really where we start building out the quality of our data, right? So you can see here, this lineage, basically what it's telling us is that we got an external source, which is an external table that is looking at a data lake. And from that, we build out staging views, right? And we're kind of breaking down that information, right? So we're saying, okay, the external table is just a flat table. It has all the data in there, but we can identify in that data that we have certain entities. Like we identified there's a station concept, there's a booth concept, right? There is a fact table concept, and so on. And this is what leads us into building that different stage, right? So we start talking about the bronze area where we start building views and start casting the information. And this is basically part of that data, which eventually those are going to use to build out dimension, right, and optimize tables. So in this case, what this is telling us is that we can see that the fact turnstile table, which is a fact table, was built by all these layers. So it started from an external table. We created the staging views for the station booth in a fact table. And then we generated dimension tables for the booth, the station, and then for those dimension tables in that staging turnstile view, we created a fact table, right? And this is important because what this does, this is the data pipeline that it will follow when we have incremental updates. So say tomorrow there's a new set of files that come in. So the external table now reflects more data that comes in that is not dimension tables and is not on the fact table. So what we do, we process this pipeline, and the incremental process is that detects that there are new stations that we have not accounted for, and maybe new booth, or maybe that we already knew all the stations and we don't need to update anything on the stations and so on. But we do need to update the fact table because those are the transactions. That is tracking all the transactions that came in, and we're associating it in such a way that is easy to query, easy to understand, and that it supports our dashboards. So lineage is important. So when you're building out your data engineering projects and you start thinking, I'm going to create tables to do this and do that, think about lineage, traceability. Make it modular, right? Make it in a way that is modular, that you understand. If something is not good, you can focus on one area, like for example, the staging area, as opposed to looking at the entire thing, right? So that will help you, and that's why this approach is very important. All right. So, and of course, as a benefit of this approach is that you start collecting data, metadata, and the metadata is for this purpose, right? As you start building out your tables, you start building out the concepts of your views, tables, you create it with metadata. So all these tables, data warehouses, and databases can allow you to create tables and allow you to create metadata associated with it. So you can actually add tags and set up areas like responsibilities and owners, right, and so on. And this is very important because this is when the executive team comes in and they want to do an audit, right? They want to do an audit on your system, which is key for data governance. You need to support audits. You can actually say, we have so many tables. These are the teams that own it. These are the teams that are using it for these different areas of the business, like financing and customer service and so on, right? And it gives you that basically information of everything that is around your data warehouse. So that is really the concept of governance, right? You have the ability to not only understand security, but understand everything, understand what is your inventory of data and security and business areas and so on. And that provides you with a report for the audit team or the executive team, and they'll be able to say that you have full governance over your data warehouse. Right. So in short, and we're gonna be looking at some code really quick. So in short, the summary for this really is to, if you follow a process-oriented architecture approach, you'll be able to understand clearly at each step what you're doing, be able to trace back to each step, and be able to review if you come across some problems, right? And you'll be able to tell the business everything that is associated with that process, right? Be able to tell them what are the assets that you have, what are the row tables you're using, the views, the tables, the optimized tables, and who's consuming them. So that's really important. So all that is the concepts and how practical this approach is, but how do we do that, right? So let's take a few minutes and take a look at that. So the first thing to show you really quick here is that what you see here, I'm flipping my screen to show you really quick here, right? Hope you can see this. Let me see. Yes, that's okay. I'm increasing this. So first of all, really quick, visit the GitHub repo. It's right here. I'll add that to the chat, but please read everything that I talked about here with more. Of course, it's more concept discovery and so on. And so please start the repo, give us a start. That helps us. So click on that start button. That helps us increase this. But this is the entire project, and this project has different areas here. So step 4, data warehouse. Our focus right now is on that, right? And we're looking at the entire data governance from the standpoint of databases and data warehouse. And here you'll see all the concepts, design and architecture, and everything of the process of how to do this. And you'll see some of the queries and the Python scripts to be able to build data pipelines and so on. So you'll see all of that here. But let's look at it from the standpoint of a data lake. So data lake here is just really is a blob storage, right? It's in the cloud. In reality, what it's doing is just building out buckets with certain files here. And all of these files that you see here are part of that external table that we're talking about. So we're following a pattern, and we're getting all these files, build out our table, and we can query this. And if you notice, we're compressing the files. So these files are about maybe 25 megs. By compressing it, we're saving a lot of space, and that has to do a lot with cost governance, right? You're managing costs, so that's important. So basically here, this is a simple example. We can see that we have several compressed files, and we want to make them available to the data warehouse. The way to do that is, I'm jumping now to a data warehouse. This is, by the way, this is Google BigQuery. It's a great data warehouse platform that you can use. So basically what's going on here is that we define the concept of an external table, right? And I'll show you the script now. But basically what it does, if you notice, it's just doing a pattern. It's just saying, load everything in this path with this particular pattern, right? That's basically what it's doing. So that is really what that does. That actually sort of materializes the data that's on that data lake into our data warehouse in the form of a table, right? So that's basically what we are doing at this point. In the script, basically, you can look at the scripts here from the save scripts, and you can kind of look at everything that is on this data set. And for example, you can open this script here. This script is basically a SQL statement to be able to build an external table, and we provide the schema definition based on the file. That's a simple file, but we actually provide the table definition of that file, and we can provide the path to it. And all that stuff is actually also available from the GitHub repo. right? But the goal here is that with the in the data set of this data warehouse, we have all these tables, right? We have the dimension tables, external tables for streaming, batch, process, streaming, and so on, right? Depending on what you're trying to do. Optimize tables, materialize views. So you will follow a convention also, right? So you can see these are views. These are basically staging views for process of reading into the external table, and all of that information is in this script. So if you wanted to see the staging views, you can basically go to the queries, and it's on GitHub, right? So I'm showing you from the standpoint of the data warehouse, but you will see how these views are built here, where we actually have the station views and so on, right? And you can actually see how we're using it, how we're actually building out the different staging areas for the data. And if you want to materialize it, because there's requirements to materialize the view, you can also materialize the view, which basically now moves it from the data lake into the data warehouse storage with some policies to refresh it, right? Because remember, that is key. Otherwise, the data is not up to date, right? So that's the quick run around here. But the more important thing is to do it from a perspective of, right? So usually you can do everything that I'm going to show you here in SQL. So it really depends on your expertise, right? But the goal here is that you can use, if you go to that GitHub project and you go to that step 4, and read the Python scripts, the Jupyter notebooks, then you can see basically what we're doing here. This script, for example, looks at the data lake. And it basically says, hey, I want to look at this path in the data lake, and I want to process all the files in that bucket. And it's just reading all the files in that bucket. So this is really the way to start staging the data pipeline. That's the end goal of this, right? You have access to the data lake, and you can actually query some of that data from the data lake, right? And actually read from that container, read the data, and do data analysis and so on. So this just shows you the ability to do that. And to run the data pipeline, we can look at this script, and it explains everything how to do that, right? And usually what's going to happen is this script here goes into a remote website, and it downloads the file. But also you don't have to go that. You can use some of the sample data sets that we have here, data, and you can query for the data of that year, that month, that day. And it actually runs a data pipeline, right, using Python, because now remember, this is that pipeline that gets the data from a remote source into our data lake, right? So it would just track every single step of the process to be able to show you how we're loading data into the data lake. And ultimately, once it's loaded to the data lake, as we query the data lake, then we'll be able to see additional files showing here. And as you query also the data warehouse, you'll see additional files showing up. So this BigQuery Jupyter Notebook now does the same thing from a Python standpoint, Visual Studio Code that I'm using right now, into querying BigQuery. So I don't have to use BigQuery Studio. I could use Python, connect to my data warehouse, and run some queries, right? I can connect, run some queries, do select statements, and I can just look at that external table that is in the data lake, that is in the data warehouse, mapping to files in the data lake. And I can run the data, look at the data, and see what's on that, right? So this also, what this illustrates is basically that you can do it either pure SQL on BigQuery Studio, or you can use Python, and you can just run queries from the data warehouse. So the idea here is that this enables us to kind of model, understand what the data warehouse needs, and understand if we want to build a data pipeline in Python, how to do it, right? So basically, this is exactly what this is doing here. right? So you get this process of data modeling, you could do it completely using SQL, or you can use it, build it using Python. And this file here covers all those details of how to run that, how to execute, how to build the dimensions, how to build all the dimensions on the system, how to build the staging views, the dimensions, the tables, and how to run the incremental update. So this logs really what they're showing you right now is running an incremental update and trying to find new records, right? And if it does, then it does a merge into our dimension table to keep the data warehouse up to date. So with this, I know it's a lot of information. We just reached, I mean, we covered a lot. I mean, we went really fast, but there's a lot more to it, right? So take time, take time to read from the GitHub repo. I pasted the GitHub URL into that. You can scan that QR code as well. It's gonna send you to a portal where you can actually take a look at the GitHub repos that I manage. They cover data engineering, AI, and web development, machine learning as well, if you want to read more around those areas. But definitely take a look at the data engineering GitHub repo. Please give us a star so we can keep growing and add to it. And you can find that book also on Amazon. It's available there. You can get the digital copy also. So I wanted to thank you. Thanks for joining us. And if you have a question, you can write it in the chat. We have a few minutes. And also I'll send an email to the community with meeting presentation and the recording that's going to be on GitHub. Okay, yes, please. If you have questions, just can you type it? I do not have access to grant you the mic. Yes, please raise your question on the chat if you can. Okay. Okay. Yes, there is high level information for sure. There's a lot of high level information. So if you follow my presentation today, you probably feel a little bit overwhelmed because there's a lot of concepts in there, right? But if you follow a process-oriented analysis and reading, so for example, I really did this to follow a very easy process to understand. First of all, understand data engineering, right? If you're saying, hey, I would like to learn about data analysis, but it's important for you to be able to do data analysis, be able to understand how to do data discovery, right? Because data discovery is a process that teaches you how to understand data, how to process data. And once you do that, then you understand what the basically the concept of the problem statement. So somebody's going to come and ask you, right, which is the problem statement. Hey, we're trying to do this, and that, right, from data. Okay, so you understand the problem statement. So your process is to understand that and then start doing your data discovery, right? And start doing an analytical, right? And understand data set criteria, data analysis criteria. It's like a lot, but what I'm saying is it's not easy to explain it in the sense that I can say just read that page. But if you read this process, and if you like Python, you follow the scripts that we have in every single phase, and you go basically you taking on a project where you actually start from understanding data, understanding data discovery, understanding design, and in architecture, right? Which probably that's not where you want to get. But if your focus is only data analysis, is understanding data discovery, problem statement analysis to understand what you need to deliver, and then jump into data analysis and visualization, right? If you don't worry about building pipelines and data warehouses and so on. So how do you start? You start in the area that you like, in the sense of if you want to do analysis, you just worry about consuming the gold zone of a data warehouse where they give you the data already curated, optimized, and you build your dashboards. But you do need to be able to understand data discovery, because you need to understand how you're going to data to the business. So that's key. So a good starting point is GitHub repos like the one I show you. You can take a look at the book as well. The book gives you more in-depth conceptual knowledge in terms about this process, but this gives you a good foundation, and then you can take on bigger projects. I hope that was helpful, everyone. Thank you. I appreciate. I'll be sending emails with the presentation, the recording, and of course, visit that GitHub repo. Give us a star, okay? Take a look at the book as well. You can download a free. I think it gives you, Amazon gives you the opportunity to download a free digital copy and read the first few pages. Take a look and see if you like it. Okay. Thank you, everyone. Have a great day. Thank you. And happy holidays.